All right, we're going to begin this new lesson on factoring trinomials, and we're going to do one specific case of factoring trinomials, and then chapter 8.6 is going to deal with the other case that we might see with factoring trinomials. All right, so looking at this page, it looks like there's a lot of letters on the screen, right? So we see something that says factoring x squared plus bx plus c when c is positive, right? So all this means, this is a quadratic expression in standard form, right? So remember, guys, that standard form just means that the exponent is going in decreasing order. You can see that x squared, that's your highest exponent, is first, and then the constant, the one that doesn't have the variable, is last, right? So this is a quadratic expression. Anything that has a squared, so this square makes it a quadratic expression. All right, now quadratic expressions can be written as trinomials. Now trinomials, you guys have seen in the previous lessons, whether it was adding, subtracting, or multiplying, and you notice that when you multiply two binomials, right, we did that by foiling. So let's say I had x plus 2 times x plus 3. Right, you guys would FOIL this like normal, right? First, outer, inner, last, or you guys would make the table, make the box. But no matter what, you would get something like, I believe the final answer for this one would be x squared plus 5x plus 6. All right, in this lesson, and for the remainder of this chapter, we're going to write these polynomial expressions as factors, right? So as factors of other little polynomials. Right, so this trinomial that you see right here can be written as a product of factors, right? So this x plus 2 and x plus 3, these are considered factors, right? Remember that factors are just numbers, or not numbers, but you guys know factors as numbers that when you multiply together, you get some answer, right? So for example, 8 has factors of 2 times 4, right? These aren't the only factors, but these are examples of factor, right? 2 is a factor and 4 is a factor. All right, so what we're going to do here is we're going to write polynomials as products of factors, right? So for example, you know that 8 is the same as 2 times 4, right? 8 is a lot simpler than if you were to write 2 times 4, right? But they have their uses, right? Especially when writing it in this way that you're going to see a lot in Algebra 2, right? So in this particular case, we're going to look at the case where c is positive, right? C being the last term here. And it can be written as a product of factors x plus p and x plus q. Now, the rule here when trying to factor is you want p and q to add to your middle term and multiply to your last term, right? That's where the factors come from, right? So let's look at these examples right here. I noticed that in this example, x squared plus 6x plus 5, the last term is 5, right? This is our c term, all right? And then our b term is this number that's in front of the x. So I want numbers that multiply to c and add to b, right? And in this case, it's going to be 1 and 5, right? 1 times 5 gets you 5, and 1 plus 5 is going to get you 6, right? And that's how you get this as your factor, as your product of factors, right? I'll show you the actual work that goes into this in the next page with the examples. But this is what it looks like. Your answer would look something like this. And to check your answer, you would typically want to try to FOIL it and make sure that you get the original expression as your answer, right? So if I were to FOIL x plus 1 times x plus 5, I want to make sure that when I multiply this, I do in fact get x squared plus 6x plus 5. And when you do that, if I did x times 5, 1 times x, and 1 times 5, and I combine my like terms, I do in fact get x squared plus 6x plus 5. All right, so that's one way to check, right? And that's what it means to factor it, right? These are our factors, right? And then this is our product right here. Similarly, if c is positive and b is negative in this case, it doesn't really matter. You're still going to have the same exact process where you want to try to find factors that multiply to C. I'll use a different color, right? Factors that multiply to C and add to B. B in this case is going to be a -6. All right, now think about this for a minute. How can you get a positive number from multiplying two numbers? You can either do a positive times a positive, or you can do a negative times a negative, right? Remember that a negative times a negative is still a positive number, right? So in this case, our two numbers are going to be a -1 and a -5, right? If I did -1 times -5, I do get +5, but when I add them, I get a -6, right? So then this is going to be your product of factors, right? And this is your factored expression. Once again, you can try to FOIL it and see that you get this polynomial as your product, all right? But your answer here is going to be this as your factors, right? And in the next page, I'm going to do some examples and show you how to go about these problems, right? Because it might be super confusing if you're just looking at it for the first time, right? All right, so this is one example where B and C are both positive, right? So remember that when C is positive, C is our last term. In this case, it's a +16. Then I know that my two numbers, P and Q, that have to add to the middle term have to either both be positive or they both have to be negative, right? Those are the only ways that we can get a positive number from multiplying two numbers, is if they're both positive or both negative. Keep in mind that B right here is a positive number, right? B is a +10, C is a +16. So I want to find factors of 16 that add to +10. And there's a couple ways that you could do this. You could write it out in a table, right? Some people like to write products of 16, right? Numbers that add to 10, and say, okay, maybe 2 times 8, right? If I did 2 times 8, and then 2 plus 8, right, you get 10, right? So 2 and 8 would be your numbers. Maybe you didn't recognize that and you did 4 times 4 and then 4 plus 4, right? Those won't work, right? Because if I did 4 plus 4, right, that adds to 8. That doesn't add to 10. If you don't want to look at it as a table, another way that you could write it out, you could just write out the factors like a little factor tree. That might be a little bit more familiar to you guys, right? So factors of 16, right? We already found our pair, but let's say you didn't recognize that and you did 1, 16, 2 and 8, 4 and 4, right? These are all factors of 16, right? And if I went and added these factors, keep in mind they want to add to the middle term, I would get 17 for these, 10 for these two factors, and 8 for these two factors. Now this is what gets me my middle term of B, right? So that means 2 and 8 are going to be my two numbers, P and Q, that I'm going to write in my product of factors, right? So this is going to become x plus 2 and x plus 8, right? Once you get your two numbers, all you have to do is write it as a product of factors that looks something like that. All right, let's do the same thing with these two examples. Hopefully you guys can kind of see the pattern as I go through these. Right, so for number 1, I want to find two numbers that multiply to C, our last term, and add to B, our middle term. Right, so in factors of 6, right, factors of 6, I have a 1 and a 6, I have a 2 and a 3. Right, these are my factors of 6. Now if I were to add them, 1 plus 6, that gets me 7, 2 plus 3, that gets you 5. Well, I know that my middle term is B. I don't want these 2 and 3 that gets you 5. I want the 1 and the 6 that gets you 7. So now once you have these numbers, 1 and 6, all you have to do is write it as a product of factors. X plus 1, x plus 6. All right, and that's all you have to do. This is your answer. All right, let's try the exact same thing with the next one. All right, so let's find factors of the last. So factors of 8 that add to the middle. All right, so factors of 8 that add to 9. Right, there's 1 and 8. And once you already find a pair, you don't really need to keep going because as you're going through them, you should be checking, right? 1 plus 8 does get you 9, right? So I know 1 and 8 have to be part of my final answer, right? So it's going to be an x plus 1 and an x plus 8. all right? And that's all you have to do in these problems. And one thing to note, it doesn't matter in which order you write them. I could have written x plus 8 and x plus 1. That is completely fine, because if you were to check and if you were to FOIL it, then you would get the exact same answer. All right, so either one of these is fine, as long as you know how to get your two factors. All right. All right, let's keep going. This is an example where b is negative and c is positive. Once again, c is our last term, and the only way that I can get a positive number from multiplying two numbers is if I have a positive times a positive or a negative times a negative. Since I want them to add to the middle term, I want them both to be negative, right? So I want to find factors of 12 that add to a negative 8. So let's consider negative factors. Keep in mind, when c is positive, like it is here, your two numbers, your p and your q, are going to be the same sign. So either both positive or both negative. So let's do, I don't know, negative 3 and a negative 4. If I add these together, I get a negative 7. Let's do a negative 2 and a negative 6. If I add these together, I get a negative 8, and that is my middle term. So I know that negative 2 and negative 6 are going to show up in my final answer. So my answer is going to be x minus 2 times x minus 8. Or I'm sorry, x minus 6. All right, keep the sign with it, right? So if you got two negatives, then it should be minus those numbers. So x minus 2 and x minus 6. All right, now here's the case where c is negative, right? Our last term can be negative, right? And in this case, the only way that we can get a negative number from multiplying is if the signs are different, right? So if I had, I don't know, a negative 2 times a positive 3, that's going to get me a negative 6. But so is 2, a positive 2 times a negative 3. That also gets me a positive 6. Right, so when c is negative, it doesn't matter what b is, right? B can be positive or negative. It doesn't matter, right? P and q are always going to have different signs, right? So you can expect your final answer to look something like this, right? It's going to have one positive and one negative, right? So in this example right here, x squared minus 4x minus 5, right? If we did our same process, I want to try to find factors of negative 5. Well, I know factors of 5 are going to be 1 and 5. Right, so since I want to find factors of a negative 5, I have to consider both options, right? So it can be either a positive 1 and a negative 5, or a negative 1 and a positive 5, right? And I want to combine them, right? So if I did 1 plus negative 5, that's going to get me a negative 4. And if I did a negative 1 plus 5, that's going to get me a positive 4. Right? Those integer rules that we went over in the very beginning of the school year are not going to go away. You need to know them for this lesson and for any lesson, right? In this course and in future courses, right? So don't mess up the signs, because it will change your entire answer, right? Notice that this negative 4 right here is what we want as our middle term. And that's how we get a positive 1 and a negative 5 in our final answer, right? So that's how we get x plus 1 and x minus 5, right? But other than that, it's the same exact process as the previous lesson. The previous problems. You just need to consider both options. All right, so let's try this one. Our c term here is negative 21, and our b term is a positive 4. Once again, it doesn't matter what sign b is. If c is negative, I know for sure that we're going to have two different signs, right? So let's look at factors of negative 21. Well, the ones that would stand out to me would be 7 and 3, right? 7 times 3 does get you 21. But since it's negative 21, let's consider both options. Let's consider a negative 7 and a positive 3, and a positive 7 and a negative 3. All right. Let's see if we combine these, if we get our answer of a positive 4, right? That's what we're looking for. So we're looking for these two numbers to add to positive 4. If I did negative 7 plus 3, that gets me negative 4, right? So not quite what I want, right? But if I did a positive 7 plus a negative 3, right? Remember, plus and negative is just minus, right? So 7 minus 3, that's going to get me a positive 4. That is what I want. So I know that 7 and negative 3 are going to be my P and Q values, right? So my answer is going to look something like x plus 7 and x minus 4, right? Again, keep the signs, all right? And that's all you have to do for that problem. All right, so there are 6 examples on this page. These same exact 6 problems are on the next page. I'm going to split it up because we might run out of room. All right, so let's start with number 3. So number 3 says w squared minus 4w plus 3. All right, keep in mind our c term here is 3, and our b term here is negative 4. All right, so I want to find factors of c that add to b. So factors of 3, positive 3, that add to negative 4. Since c is positive, I can expect that my two numbers are going to have the same sign. And since b is negative, I know that they're going to both be negative, both of my factors of positive 3. All right, now my only factors of 3 are going to be 1 and 3. All right, but since b is negative, we're going to use negative 1 and negative 3. Now, this is really your only option, but you can test it out. If you add them together, you do, in fact, get negative 4. All right, so these are going to be my two numbers, my P and Q. So w squared minus 4w plus 3 is going to get you w minus 1 and w minus 3. Once again, I haven't been doing it throughout, but if you aren't confident in your answer and you want to check, you can always FOIL it and make sure that you get your original expression as your answer. All right, so let's do the same thing with number 4. So I'll do 3, 4, and 5, and in the next page I'll do 6, 7, and 8. So number 4 says n squared minus 12n plus 35. So once again, my c term is positive, my b term is negative. So I can expect that my two numbers are going to be both negative, right? Because if c is positive, only way that you can get a positive is if you do positive times positive or negative times negative, right? So factors of 35 that add to negative 12. Well, you can think of negative 5, negative 7, right? If I add those together, right, check what you get. We get negative 12, and that is, in fact, our b term, right? So in this case, I didn't have to do much. If you tried different factors, then you would have to keep going until you find a pair that actually works, right? But in this case, we found a relatively simple one that works, right? So I know that n squared minus 12n plus 35 is going to be n minus 5 and n minus 7. All right, so let's keep going. Let's do number 5 on this page. All right, so number 5 is x squared minus 14x plus 24. Once again, factors of 24 that add to negative 14. Both have to be negative. All right, so I know that c is 24. So let's find factors of 24. We can do negative 6 and negative 4. Negative 8, negative 3. All right, negative 12, negative 2. We got a good handful. If these don't work, we'll just find more. But if I did negative 6 plus negative 4, that's going to get me negative 10. Right, not what we want. Negative 8 minus 3 is going to get me a negative 11. Also not what we want. Negative 12 minus 2 is going to get me a negative 14. That is what we want, right? It matches our middle term. Right, so my two numbers, P and Q, are going to be negative 12 and negative 2. So that means my answer for this one is going to be w minus 12 times w minus 2. All right, so we're going to finish with 6, 7, and 8. Number 6, I have an x squared plus 2x minus 15. All right, so because c is negative in this case, right, 15 is our c term, we can expect that our answer is going to have one positive and one negative, right? So factors of negative 15 that add to negative 2, well, let's pick a couple, right? Factors of 15, ones that stand out to me are going to be 3 and 5. So why don't we do negative 3 and a positive 5 and a 3 and a negative 5, right? So let's combine these and see what we get. If I did negative 3 plus 5, that gets me a positive 2, and that is what I want, right? That is our middle term. So I don't even need to check the rest. As soon as you get one that works, you can just use that as your answer, right? So x squared plus 2x minus 15 is going to get me an x minus 3 and an x plus 5 as my factors. All right. And we can do the same thing with number 7, right? So number 7 is y squared plus 13y minus 30. All right, so let's find factors of the last that add to the middle. Factors of 30 or negative 30, right? Because it's negative, I can expect the two signs to be different. So let's try, maybe ones that stand out to me are going to be 10 and 3, right? So we can do negative 10, positive 3, or positive 10 and negative 3. All right, so let's try these and see if they work. If I did negative 10 plus 3, that's going to get me a negative 7, right? And that's not what we want. We're looking for a positive 13. If I did 10 minus 3, that's going to get me a positive 7. Also not what I want. I will want a positive 13. So some of you might see the 10 and the 3, and you might think that that's going to add to 13. Keep in mind the sign matters here. The sign is going to tell us whether it works or not. So that means I need to pick different factors. Some other factors of 30, maybe 2 and 15, right? Because I want to multiply to a negative 30, right? One of these should be negative, the other one positive. So I can do a negative 2 and a positive 15, or a positive 2 and a negative 15. And let's see if those get us a positive 13. If I did negative 2 plus 15, that does get me a positive 13, right? So that means my two factors for this polynomial is going to be a y minus 2 and a y plus 15. All right. And now lastly, we're going to do the last one, which is v squared. All right, so number 8 is v squared minus v minus 42. Our last term c is negative 42, a negative number, so I can expect that they're going to add, or I mean that one's going to be negative, one's going to be positive. And they want them to add to negative 1, right? Keep in mind, if you don't see a coefficient, assume it's 1. So factors of negative 42, a couple of things might stand out to you. I would pick 6 and 7, right? If I did 6 and 7 and I want them to add to a negative, we can do a negative 6 and a positive 7, or a positive 6 and a negative 7, right? And if I did these, if I did negative 6 plus 7, that gets me a positive 1, right? That's not what I want. I want a negative 1. If I did 6 plus negative 7, that gets me a negative 1, right? And that is what I want. So that means my two numbers are going to be a 6 and a negative 7. So this polynomial is going to factor as v plus 6 and a v minus 7. All right, so that's a lesson on factoring. This is the most basic case that you might see. And the more you do it, the easier it'll get, right? Down the line, hopefully this becomes second nature to you, right? But for now, it might be a little bit of a challenge, right? You just have to get used to the process. All right, and this is a little flow chart that kind of summarizes the three different cases that we saw, right? So there are two cases where C is positive, and the difference between the two are when B is positive and B is negative, right? So we either get that P and Q are both positive, P and Q are both negative, or if C is negative, then my two numbers P and Q need to have different signs, right? So this is just a little summary of the different cases that we saw in this lesson, right? And it's only going to be limited, at least in this part of it, to these three cases.